Hi friends, in the continuation of data science interview question answer series, we are moving to question difference between classification and regression features. Output type. The classification output variable is categorical, discrete, nominal or quantitative. In regression, the output variable is continuous, real valued, quantitative. Nature of prediction predict a class label or category. Regression predict a quantitative or magnitude. Output example yes, no, spam, not spam, cat, dog, real, red, green, blue. In regression, price, temperature, age, sales value, subcategory, classification, binary classes, two classes, or multi-class more than two classes. In regression, univariate, one output, or multivariate, two more than one output. Error measurement. In classification measurement, the classification rate whether the class was predicted correctly. In regression, measure the distance between the predicted and actual continuous value. Primary metrics in classification, accuracy, precision, recall, F1 score, AUC. In regression, its measurement, mean, square error, root mean square error, R2 score, goal. The classification to learn decision boundaries to separate classes. Regression to learn a mapping function, line, curve, hyperplane to fit the data. Common algorithm in classification, logistic regression, SVM, decision tree, naive Bayes. In regression, linear regression, polynomial regression, SVR, support vector regression. Moving question difference between feature selection and feature extraction. Primary objective in feature selection to choose a subset of original most relevant feature. In feature extraction to create new feature by combining and transforming the original feature. Nature of feature selection retain the original feature interpretable. In feature extraction, generate new synthetic feature, often less interpretable. Data transformation. In feature selection, no transformation, simply filter or wraps around the existing features. Feature extraction involve mathematical transformation, example linear combinations. Information loss. Feature selection, minimal loss, focusing on eliminating redundant or irrelevant features. Feature extraction can lead to some loss as the goal is dimensionality reduction. Example PCA, principal component analysis, discarded lower variance component. Technique type in feature selection, filter method, example chi-squared, correlation, wrapper method, example RFE. In embedded method, example lasso. In feature extraction, dimensionality reduction technique, example PCA, LDA, T, SNAE, autoencoder, dimensionality. In feature selection, usually result is a smaller set of original features. Feature extraction always result is reduced number of feature dimensions. Model complexity. Feature selection reduce complexity by removing noise and irrelevant variables. In feature extraction, often simplifies complex data representation, potentially capturing more signal. Interpretability high. In feature selection, it's high. Feature retain their original meaning. In feature extraction, low. New feature are combination, principal component, latent factors. Moving question, difference between generative model and discriminative model. Modeling focus. Models, the joint probability P, X, Y, how data X and label Y are generated. In discriminative model, model is conditionally probabilities $P, Y. Primary goal to understand the underlying distribution of the data and generate new sample. In discriminative model to classify a given input X into one of the available classes Y. Prediction method calculate the likelihood of X belonging to Y via Bayes theorem Py. In discriminative model, its prototype of X training data need require more training data to accurately model the complex underlying distribution. In discriminative model can perform well with less training data as it only models the boundary, handling missing data. Generative model can handle missing data and feature by modeling the full distribution. Discriminative models cannot inherently handle missing data well without imputation. Asymptotic error often have lower asymptotic error as the training set size approaches infinity. Discriminative models generally have high asymptotic error but are faster to coverage. Typical algorithm: naive Bayes, hidden Markov model, GAN, generative adversarial network, ES, variational autoencoder. In discriminative model, logistic regression, support vector machine, perceptron, conditional random fields. Use cases: image, text, audio generation, anomaly detection, modeling, complex system. In generative model, in discriminative model, standard classification and regression task. Movement question: difference between parametric models and non-parametric model. Assumption: make strong assumption about the functional from the relationship. Example: linear normal distribution. Non-parametric model makes minimal or no assumption about the functional form of the relationship. Number of parameter a fixed in finite number of parameter regardless of training data size. In non-parametric model, the number of parameters grow with the size of the training data set. Model complexity. Parametric model simpler structure model is fully defined by its parameter. Non-parametric model more complex structure, more complexity, scale with data, overfitting risk, lower risk of overfitting due to strong structural assumption, higher bias. In non-parametric model, higher risk of overfitting as they can fit noise in the data, lower bias, high variance. Prediction speed generally faster for prediction once the parameter are learned. Non-parametric models generally slower for prediction as it often require calculation involving neighbors. Example: KNN. Interpretability. In parametric model, high the meaning of the learner for learned parameters is usually clear. Non-parametric model, lower the model behavior is tied to data point themselves. Typical algorithms: parametric model, linear regression, logistic regression, naive Bayes, linear SVM. Non-parametric model, k-nearest neighbor, decision trees, random forest. Non-parametric regression, data efficiency. Parametric model more data efficient, can perform well with a smaller data set if assumption holds. In non-parametric model, less data efficient usually requires more data to achieve good performance. Please like, subscribe, and share the channel. Thank you.